Today I want to look at how we can find the rate of a reaction by looking at a graph of the concentrations of the reactants and products over time. The rate at which a reaction occurs is essentially the rate at which reactants are consumed or products are produced. That is, the rate at which the concentrations of various substances change over time. We can find that pretty easily on a graph like this, which shows the concentrations of different substances at different times. For example, if we wanted to look at the rate at which N2 was produced, we could simply look and say that over the course of the entire reaction, it increased from 0 to 900 over the course of 3 seconds. That's an average rate of an increase in 900 millimolar over 3 seconds, or 300 millimolar per second of N2. But that's the rate over 3 seconds, and that would assume that this were a linear graph. We can see this graph is not linear. It definitely has some curve to it. So it's best to find the average rate over shorter time periods. For example, if we wanted to find the rate over, say, the first half second, well, if we look there, this actually is a pretty linear line over the first half second. It's pretty close. So in this case, the rise over run formula is a pretty good approximation of the slope during this time period. So at this point, the rate for N2 looks to me like that increases from about 0 to 310. So we have 310 at 0.5 seconds. It was 0 at 0 seconds. And this is for N2. So the average rate for N2 over the first half second would be a rise of 310 minus 0 over a run of 0.5 minus 0, or 620 millimolar of N2 per second. Okay, so we can see that the rate over the first half second is actually quite larger than the rate over the whole 3-second time period. Well, let's have a look at the last half second. The last half second, that is from 2.5 to 3 seconds, looks to me like it increased from 850 to 900. So again, over the last half second, we went from 850 at 2.5 seconds to 900 at 3 seconds. Again, for N2, our rise is 900 minus 850 over 3 minus 2.5, or 100 millimolar of N2 per second. Okay, a much slower rate over the last half second than it was over the first second. So we could do this for any time interval, and we can find that the rate that any substance is produced or consumed should decrease over time. And hopefully this makes sense. As the reactants are being consumed, the reaction rate slows down. Okay, for the homework, you'll be practicing doing this over several time intervals, and ultimately you're going to be asked to graph, in the last 2 questions, to graph the average rate of reaction versus the concentration of N2O. So note, the graph that you're given is concentration versus time. You're going to try to make a graph of concentration versus rate, or I should say rate versus concentration, to see how they're related. Okay, if you have any questions, please let me know on Google Classroom or email. Have a good one.